Once we created the project, we will end up with this graphical tool that allows us to easily configure peripherals. Okay, so from the left side we have different peripherals, and also we have, as you see, graphical representation of the microcontroller. And another thing which is really important is the clock configuration. Okay, so here I have, as you see, 80 megahertz clock frequency, okay, which is the system clock. And you might, if you're using different microcontroller, you might have different clock frequency. And it is desirable to achieve the maximum frequency, so your microcontroller works really fast. And usually you can find that information just over there, as you see, 8 megahertz maximum. So since I already have the maximum frequency, I will not do any changes. But if you have like a less frequency, let's say 20 megahertz, you can just apply with these parameters to achieve higher frequency. Okay, so for example, here I can put 15 and it will show 120 megahertz. But since I cannot do it because the maximum frequency is 80 megahertz, also I have some issues here. It will show the problem with the red color. So you just need to play with these parameters to make sure that everything is fine and that you have the maximum frequency. Okay, and we can actually start coding, but it is quite important to prepare debugging tools. And one of the commonly used debugging tools is, of course, printf function. So you can print variables and you can see whether your code is working or not, properly or not. However, when using the microcontroller, there is no easy way to implement printf function, because everything is happening inside of the microcontroller, and you have to somehow send data to computer, and also you have to display the data on the screen, on the display. So it is a bit complicated. However, when using STM32 microcontrollers, we have we have a tool called Serial Wire Viewer, and this tool allows us to easily implement printf function. In addition, it has a cool feature which is plotting the variables in real time, so you can see in real time how your data is evolving. I think it is pretty cool feature and I use a lot in my projects. So enough words, let's configure a Serial Wire Viewer. I already released some videos on my YouTube about a Serial Wire Viewer, and also have an article on my website, so you can follow the instructions there, and you can find the links on the description. But in addition, you can just follow me. So I'm going to show all the steps to configure Serial Wire Viewer. So the first thing, we have to make sure that we have this serial wire output pin, which is PB3 in most of the cases. So you have to make sure that you have this pin as you see on my project. If you don't find it, if you have any problem at this level, of course, you can leave some question in the discussion section. Next, we have to make sure that we have this write function. Okay, to do that, we can just press Control S to store our file, so it will generate code for us. So I press remember my decision and then yes. Okay, I have the code generated, and what I do, I just copy this part, this code, and I put it on my code. And you can find that piece of code in the description of this lesson, of course. So also it is quite important to write our code between these comments. So when we update this IUC file, our code will not be erased. Okay. Then what we can do, we can just press this build button to make sure that we don't have any error. Okay. Next, let's look what we need to do. We just need to copy these lines of code. So we're going to test the printf function by writing hello world on the data console. Okay, so I hope you're familiar with HAL delay function. So every 1 second, we're going to print the hello world function, hello world text on the console. And then we need to include stdio.h library. It is not mandatory, but it will show that warning. So I usually include this library. Okay. Next, we need to connect the microcontroller. Make sure that you have connected the microcontroller to your computer. So we press this button. So we have a debugger configuration. Then just open this debugger. And here we need to enable serial wire viewer. And to this place, and here you need to write the frequency of the microcontroller, the operating frequency of the microcontroller. You can find it inside of the IUC file, inside of the clock configuration, as I showed you. So I have everything ready. I press apply, then OK. So we going to flash the microcontroller and we will debug it. So we have successfully debugged the microcontroller, and what we need to do, we have to open a serial wire viewer data console. So inside of window, show view, as SWV, and here you need to choose data console. Okay, then press this configure trace button. And here you just need to enable port 0. So you have to tick this box. Then we press OK. Then we press this red circle. Then when we launch the code, so we resume, and you have to get hello world text in every 1 second. So it means that our code is working, so we can print the text or any data, which is quite useful when debugging the code. And next, I'm going to show another feature which is plotting the variable in real time.